Well, now that we know how to find the derivative of a product, the natural next thing is to try to find the derivative of a quotient. So if we have a function q of x, which is f of x over g of x, we'd like to find the so-called quotient rule, a formula for q prime of x. I will leave it to you to experiment with just basically any function you can pick. Take some f of x over g of x and take their derivatives, and you will find that it's not going to be f prime over g prime, just as it was for products. It's not that easy. So how can we do this? You notice that I haven't written up the limit definition yet because I would like to avoid using the limit definition. Whenever there are people here in the room with me, I say we can do it the long way with a limit definition. It'll be very painful, but if somebody can come up with a better idea, then we'll do it a better idea. Mathematicians are lazy. We would like to avoid work as much as we can. We would like to use things we've already done as much as we can. So how could we do something with this that we would use something we've already got? In particular, the thing that we just figured out. The thing that we just figured out was the product rule, right? So how could we turn this so that it's not a quotient but a product? We can multiply the g of x to the left side. So I can have g of x, q of x, equals f of x. And now I can take the derivative of each side. And on this side, I'm going to use what we just figured out, the product rule. This is very nice. So on this side, when I take the derivative, product rule says take the derivative of one piece. So say we take the derivative of g of x, multiply that by q of x. Then we leave the g of x alone. And we take the derivative of q of x, which is called q prime of x. And since this is an equation, if we want to maintain equality, you have to do the same thing on both sides. Since we took the derivative of the left side, we have to take the derivative of the right side. And remember, what are we trying to solve for here? We're trying to solve for q prime of x. So now it's an algebra problem. We want to move all the rest of this stuff, so we'll start by subtracting this. So we've got g of x, q prime of x, equals f prime of x, minus this stuff, g prime of x, q of x. And again, since we're trying to solve for q prime of x, we should divide by g of x. So q prime of x is f prime of x minus g prime of x, q of x, all over g of x. But this looks a little funny, right? Because we've got this q of x in here. We would like a rule that just had f's and g's in it. But we know what q of x was. In terms of f and g's, it was f over g. So this is going to be f prime minus g prime of x. Q of x was what? F of x over g of x. And this is still all over g of x. And you could stop there, and you could say this is your quotient rule. But it looks a little ugly to have a fraction inside of a fraction. We sometimes try to avoid that. So to avoid that, we can just multiply both the top and the bottom of the fraction by g of x. So yet another example of multiplying by 1 in a clever way. So when I do that, this g of x multiplies all the way through. So I get q prime. Now I have f prime of x, g of x. Over here, the g of x cancels on the bottom. I'm just going to rearrange these terms so that it matches what we had for the product rule. You don't need to do that. G prime of x. And then I multiply g of x by g of x on the bottom, and we get g of x squared. So there we have it. We didn't have to use the limit definition because we had already done the product rule. And this is going to be a theme next week as well. We're going to use something we already know in order to get another derivative rule for very little work than if we were to try to do it from scratch. So let's just summarize this in one place here. This is the quotient rule. It says if you want to take the derivative of f of x over g of x, this is what you do. F prime of x, g of x, minus f of x, g prime of x, all over g of x squared. And you'll notice that unlike with the product rule, the order does matter here. So because the product rule we were adding on the top, and adding is commutative, right? 3 plus 5 and 5 plus 3 are the same. But here we're subtracting, so the order matters. So you have to always start by taking the derivative of the top times the bottom. So we'll put this in a box. And then we will do 2 practice problems, and that will be it for this week. So let's find the derivatives, dy dx, for these 2 functions. So we've got a quotient. Quotient rule says you start with the derivative of the top. So we take the derivative of the top, which is 5 to the x, ln 5, and we multiply that by the bottom. Then the quotient rule says we leave the top alone, 5 to the x, and then we take the derivative of the bottom, so 7x to the 6th. So this is, if I'm calling the top f and the bottom g, this is f prime times g minus f times g prime. All that we're missing is g of x squared on the bottom. And as usual, you do not need to simplify. If you want to simplify, that's fine, but you don't need to. Let's try this one. So quotient rule says you start with the derivative of which one, top or bottom? We have to start with the derivative of the top. So the derivative of x squared is 2x. 11 is an adding constant, and we know that the derivative of any constant is 0. So we get 2x, and we multiply that by the bottom. Right? And we need those parentheses because the 2x has got to multiply the entire denominator. Minus, now it says we leave the top alone, that's f, x squared plus 11. X squared plus 11. And now we take the derivative of the bottom. 13 is a constant, so its derivative is what? 0. And we have negative e to the x, so its derivative is negative e to the x, all over the denominator squared. And here it's not really any simplifying you can do. Sometimes people are tempted and they try to cancel out this 13 minus e to the x with one of these. Is that legal algebra? That is not legal algebra, right? Because there is no 13 minus e to the x term here. So these cannot be canceled by any legal algebra. This is really just the way to leave it. All right, that's half of our derivative rules. We spent 1 week getting half of them. We'll spend next week getting the other half. And then after that, we'll be able to apply these derivative rules all over all sorts of different problems. For now, we have a check your understanding for you on the product and the quotient rules.